3.2a, Introduction to Multiple Step Equations. To solve multiple step equations, we need to work backwards in regards to PEMDAS to undo the operations. So we first undo addition and subtraction, and then we undo multiplication and division. So let's go through a couple examples of working backwards to undo these equations. So we're solving for x in example 1. So solve 4x plus 3 equals 11. So what I mean by working backwards is we need to go in the opposite order of what PEMDAS usually tells us. So in PEMDAS it says that multiplication and division should always come before addition and subtraction. Well, if you think about it, when we're solving equations, we're actually working backwards in some respects. So we have to work backwards up PEMDAS to get x by itself. So first, let's do the subtraction principle. So we subtract 3 from both sides. So we get the x term by itself. So plus 3 and minus 3 cancel, and 11 minus 3 is 8, and we have 4x. So 4x equals 8. So we have the x term by itself. But we need to get the variable x by itself. And to do this, we have to employ the division principle. We can see this because it's multiplied by something, and we're trying to undo that. So let's divide both sides by 4. And the multiplication and division cancel out because they're opposite operations. 8 divided by 4 is 2. So x equals 2 is the solution to 4x plus 3 equals 11. Now we can check this just like before, by plugging in x equals 2 for x. So if you plug in a 2 here, 4 times 2 plus 3 equals 11, and we carry out PEMDAS as usual, so we multiply 4 and 2 together, so that's 8 plus 3 equals 11. So 11 equals 11, and this is a true statement. So our solution of x equals 2 is a correct solution to this equation. Let's go through another example. Solve b over 2 minus 1 equals 10 for b. So first off, we want to get the b term by itself. And working backwards from PEMDAS, we should use the addition principle before the multiplication principle. So let's add 1 to both sides to get this b over 2 term by itself. Now the plus 1 and minus 1 cancel here on the left-hand side, like we wanted to. And the 10 becomes an 11. 10 plus 1 is 11, and this is b over 2. Now we see that to get rid of this divided by 2, we should multiply by 2 on both sides. So we're going to use the multiplication principle to multiply both sides by 2. These are opposite operations. 2 times 2 and divided by 2 are opposite operations. So b equals 11 times 2, which is 22. And that's our answer. We could check like before by plugging b back into the original equation.